Let's look at something called isoelectronic electron configurations. Isoelectronic simply means any species that has the same number of electrons. And if they have the same number of electrons, that means they have the same electron configuration. But let's think about ions. Ions, of course, also can have an electron configuration because ions are atoms that have electrons. So those electrons are residing in orbitals somewhere. Well, what orbitals they reside in is going to be your s, your p, your d, your f subshells, and your principal quantum numbers. All that stuff applies same way. Same thing with your spin quantum numbers. And so if we can figure out what the electron configurations are for each of these ions, then we can compare them to other elements or other ions, and then we're able to say, oh, this one is isoelectronic with, and then we can list things that it's isoelectronic with. All right, so all we're doing is figuring out which ions and atoms have the same number of electrons. Another way of saying that is which ones have the same electron configurations. So let's try 4 of them and see what we can learn. The first one I want us to look at is the potassium ion. So if it is positively charged, normally we have 19 electrons, but that is only if it's neutral. So what if it's positively charged? If it's positive, remember that means it lost an electron. So if it lost an electron, how many electrons does it now have? 18. So the easiest way to do this is just go, oh, hey, that means it has the same electron configuration of argon. All right, so what is its electron configuration? It is therefore 1s2, 2s2, 2p6, 3s2, and 3p6, which is the exact same as argon. And so it's isoelectronic with argon. If you write the shorthand, that would be neon, and then 3s2, 3p6. So what is potassium isoelectronic with? Oh, definitely argon. Anything else? Absolutely. What else? What about calcium? If calcium is 2+, how many electrons does it have? It has 20 minus 2 electrons gives it 18 electrons. So it's also isoelectronic with argon. What about sulfur ions or chlorine ions? Both of these also have 18 electrons because sulfur had 16 and then it gained 2 electrons to become 18. Chlorine had 17 electrons. In order to become more stable, it added an electron to take on noble configuration. So what elements or species are isoelectronic with potassium? You could say argon, sulfur, chlorine, or even calcium, okay? Or I guess if gallium is also a 3+, it could be that as well. All right, so that's all isoelectronic is meaning. What stuff has the same number of electrons? And because of that, what's its electron configuration? So when you're asked a question such as, what is the electron configuration for magnesium ions? You first have to identify what is my ion. So magnesium has a 2+ charge. And then you need to look and say, how many electrons does it have? So it starts out with 12 electrons, which means then it lost 2, because 2+ means you lost 2 electrons. So it begins to look like sodium, and then it begins to look like neon, because 12 minus 2 means it's isoelectronic with neon. So what is its electron configuration? 1s2, 2s2, and 2p6. But notice, that means that it's isoelectronic with neon, with our fluorine, with our oxygen, okay, with our sodium ions. So, but not oxygen, I mean O2 minus ions, fluorine ions, sodium ions, okay? It is not isoelectronic with magnesium atoms. Absolutely not, okay? So when you're first asked to find the electron configuration for an ion, the first step is just figuring out how many electrons does it have. Once you figure out how many electrons it is, it's a rather simple situation. Let's do 2 more for practice. So the next one is oxygen. What's the electron configuration for oxygen? If it has a -2 charge, then that means it's going to gain 2 electrons. 1, 2. So it's actually the same as the previous one. 1s2, 2s2, 2p6, making it isoelectronic with everything that we've already discussed. That of neon, fluorine, sodium, magnesium. Let's do one more. Chlorine. All right, chlorine, -1. That means how many electrons does it have? 16 electrons. It lost one. It gained one, excuse me. So it gained one. Now it looks like argon. So its electron configuration is 2s2, 1s2, 2s2, 2p6, 3s2, and 3p6. And so it is isoelectronic with argon, sulfur 2-, potassium, and calcium. Okay. So this principle is just something that allows you to look at the periodic table and think through, how does stuff become isoelectronic? It turns into an ion. Everything wants to be like a noble gas. So that means when you add or subtract electrons to become more stable, you're allowing it to have the same electron configuration as a noble gas. Does that mean the size of the atoms are the same? No, and we'll learn more about that in our next video, because things have different number of protons. So if they have different number of protons, the attraction between the nucleus and those outer electrons changes. But do they have the same energy levels? Do they have the same types of subshells? Absolutely. And that's what being isoelectronic is all about.